Hello guys, it's a very simple thing to remember about the even functions. Even function, one thing is they are symmetric to y-axis. They are usually have even power, and if we put the negative value, they still give us the positive value of x. An equation, if you put the negative value of x, it still gives you the positive value of x. So it means we have to go through an examples. For the examples, we have its parabola. We know it's a scalar function. We put 2 in there and we get 4. For -2 we got 4. Also, it relates to the even power that, like I tell you here, so we should know it's an even function, and it's symmetric to y-axis. You can see the fact about the y's. And for the second example, we take an absolute value function. We know what absolute value function. It's absolute value is the distance from 0 on a number line, and it's always positive. So if we put -4, it still gives us a positive value. If we put +4, it will give the positive value. So it's because it's a distance, it's always positive, and it's symmetric to y-axis. You can see. All right, you can see we put -4, we still got positive value. Here it says -4, negative value, we still got positive. Now moving on to cos value function, cosecant. Cos value function, we know if we the sine value of 90 is 0, but cos of sine value of 90 is 1, but cos value of 90 is 0. So at 90 the value goes to 0, and at -90, if we go right there from theta, move from here to here in a clockwise direction, it still give 0 value. There you go. And it's symmetric to y-axis. Also, one thing to notice, there's an inverse function of cos, reciprocal function. It's called secant function. It is also symmetrical. So we take the example right there for the secant value function. Secant value function, we know that here when the cos of 90 is 0, the secant, the opposite of 90, is undefined, because it should be 1 over 0. Alright, it's undefined, so it gives us the vertical asymptote at 1, but it's still symmetrical to the y-axis. You can see the symmetry. Alright, now we goes to the algebraic example. So if we given the value of 6x6 plus 2x2, we can definitely easily find it. If we can look, it's an even power, it's an even power again. So, and also for finding it's an even and odd, if we don't realize, still we just put the negative value of x. If we find the positive value of x, it means if it's an even function. Right there, put negative value, because if it's a positive power, it's a even power, it still gives the same result. Here, if you put one value here, and it should give 8. If you put -1, it still get 8. So 1, 8, -1, 8, -1, 8. So if we change the axis, it still gives the same by value. You can see, as it mentioned there. Thank you guys.